Continuing on in chapter 6, we're finally out of the land of all those formulas. We're going to be looking at solving equations. And these equations, no surprise here because we're learning trigonometry, are going to be trigonometric equations. In other words, equations that are going to have our trig functions, sine, cosine, tan, and so forth in them. So in your notes here, I put down the general steps for these. Might not make so much sense now, but as we go through some examples, we'll come back to take a look to make sure they do make sense. The first step we're going to take is to isolate or to get the trig function on one side of the equation. And we're going to use the same algebra rules that we know and we use to solve equations, but instead of getting a variable on one side, it's going to be a trig function. So our variable is going to be locked into either sine or cosine or tangent. And we're going to get that, as it says, all by itself on one side of the equation and the other information on the other side. Next, we're going to solve for the variable. So when we get the trig function on one side of the equation, we're not going to be done because our variable is still going to be locked into the trig function. So we're going to solve for that variable. In other words, we're going to be solving for the angle because our variable, x or whatever we call it, is going to represent some angle. And last but not least, we're going to make sure that all the solutions that are being asked for in each problem are shown. Because remember, trig functions are periodic, which means they go through cycles over and over and over again. So we could spend the rest of our life or the rest of our time in captivity because of this coronavirus cranking these out. We're not going to do that. I'm sure you're sighing a relief there. But we are going to have to make sure we show the ones that are being asked for. So just as a little refresher, well, first let's take a look at this example. We have 5 times the sine of x is equal to 3 sine of x plus the square root of 3. Our mission here is to find out what x is. But first, we want to get sine of x all by itself. So now back to my thought of let's do a little bit of review of the steps we would take to solve this if instead of solving for sine x, we're solving for just plain x. So here I'm going to call this u because it might be confusing. We have x's here. I don't want to use x's here also because it's not the same thing. So we have 5u is equal to 3u plus square root of 3. So same problem here, but now instead of solving for sine of x, we're just going to solve for u. And we know to do this, we would subtract 3u from both sides. And so 5u minus 3u, we have 2u is equal to square root of 3. And then finally, we divide both sides by 2. And we end up with u is equal to square root 3 over 2. So if this was a problem with strictly algebra, that would be our answer and we would be done. So let's come over here and repeat the same algebra that we did here, but now it's going to be in terms of sine of x. So notice we're just going to treat this trig function sine of x as like a chunk of information and do the same algebra process. So subtract minus 3 sine from both sides. 3 sine x, I should say. 5 minus 3, there's the same 2, but this time it's sine x, so same logic. And we're left with the square root 3. We need sine x by itself, because remember we want to isolate or get that sine function by itself. So we divide both sides by 2. Whoops. And now we have the sine of x is equal to square root 3 over 2. So we are not done here because we're not looking for the sine of x. We want to find x. So in order to find x, you could use your calculator to do inverse trig functions. However, we know this angle here, this ratio. We recognize this ratio. It is pi over 3, or 60 degrees, that has a sine of radical 3 over 2. So our x is going to be pi over 3. Now, pi over 3 is from Q1. And so something that we have to keep in mind when we get these, when we're solving these equations is coming back to this ratio here. This ratio here is positive. So positive. When we think of our trig functions, for sine, the normal period is 2 pi. And in 2 pi, we have two quadrants where sine is positive, Q1 and Q2. So whenever we solve an equation, we have to consider what two periods are going to give us a positive angle or what two periods are going to give us a negative angle. And here, sine is also positive in Q2. So in Q2, the angle would be 2 pi over 3. Remember, the reference angle is going to be pi over 3. So when we look in Q2, it's going to be 2 pi over 3. That has the reference angle of pi over 3. So these are our answers. And these are from our normal period, which is 0 to 2 pi. Now, I just want to point out here, if you notice, when I wrote this, I wrote 0 is less than or equal to x. So we can count 0 as a solution. But over here at 2 pi, it's just less than. Because remember, with sine, the sign of 0 and 2 pi are the same thing. We're back to where we started. So we don't need to duplicate unnecessarily. So it'll be 0 included, but up to 2 pi not included. Looking at this problem, we're looking at sine of x, or down here, we can see it clearly. Sine of x, we haven't changed the period, so this 0 to 2 pi is going to give us all our solutions. However, in this, I do want to consider, I didn't write it, but I do want to consider all solutions. So in order to show all solutions, how I'm going to show that is pi over 3, our angle from Q1, then plus 2 pi over n. And now for this, let me put commas here and make it fancy. For this solution, it's going to be x is equal to 2 pi over 3. And again, plus this 2 pi n. And this is going to be all solutions. So if we are doing a problem and it's requested that we provide all solutions, we're going to tack on this 2 pi n and 2 pi n. Why? Because sine needs a cycle of 2 pi to repeat our answers. Every time we add another 2 pi or 360 degrees to pi over 3, we're going to get another angle that gives us the same solution. And this n just shows us that it's not just one 2 pi we can add. We can keep going and going and going. So if we had n is 1, we would add 1 2 pi. If n is 2, we would add 2 pi, so we'd be adding 4 pi, and so on. So this would keep us going on and on and on and on and on till we couldn't stand it any longer to get all the solutions. As I said, we're not going to crank them all out here. We're just going to represent them with this notation. Going to this example here, I'll switch to another color. It's going to be the same algebra that we're going to consider when we do this problem. In this particular example, we're looking to solve for the tangent of x. So I'm seeing tangent on this side and tangent on this side. So first thing I'm going to do is subtract tan x from both sides. And now I have 4 minus 3. I have the tangent of x minus 1 is equal to 0. This is algebra we know already. So now I want to move this negative 1 over, add 1 to both sides to get the tangent of x is equal to 1. Again, we have to pay attention to the sign. This is sign being positive or negative, not the other kind of trig sign. So we're considering now the tangent of x is equal to 1. We're not done. We want to know what angle has a tangent of 1. And again, you could use your inverse tan function on the calculator, but no need because you know this or you should know this. The angle that has a tangent of 1 is going to be x is equal to pi over 4. Now, tangent has a period normally of 0 to pi. We don't need a full 2 pi for tan. We only need between 0 and pi. And between 0 and pi, again, looking here, this tangent, we haven't changed the period of it, so it's our normal pi, and I'm doing it from 0 to pi, not negative pi over 2 to pi over 2. It's the same pi. I'm just doing it from 0 to pi. If we consider between 0 and pi, in Q1, tan is positive, and in Q2, tan is negative. So in our normal period for pi, if our tangent is positive, we only have to look to Q1. So we get the pi over 4 and are done. We don't have to go looking in another quadrant because we're limiting our period to just 2 quadrants, Q1 and Q2. So if it's positive, Q1 and we're done. If this was negative, we get the angle from Q2 and we would be done. So this is our answer between 0 and pi, which would be our normal period for tangent. And now, again, if we want all solutions, what we're going to do is take our pi over 4, and in this case, instead of adding 2 pi n, we're going to add pi n. And this is all solutions. So this solution here is a particular solution from 0 to pi, and when we tack on this pi n here, this would give us all potential solutions. And I forgot to mention here, but I'll mention it here, n is also able to be a negative integer. So we could have adding pi over 4 plus negative pi if n was negative 1. If n is negative 2, it would be negative 2 pi. So pi over 4 plus negative 2 pi would give us another solution.